This is Mr. Waltz. I'm going to show you how to make the rotor for the fidget spinner. What we're going to do up here is click New Project, and fidget spinner is what you guys could call it. I'm going to call mine the demo because I have a bunch of these. Close the data panel, and we're going to go get our ball bearing that we're going to use for this. That's the first part we're going to work on. So we're going to go up here where it says Insert, click Insert McMaster Car Component. And in the search bar here, we're going to type 608, 608, 608, and it'll show 608 ball bearings. That's the kind of bearing that is usually used for fidget spinners. The one we want is a 608 2Z, so I'm going to click that. And you can see it'll show it here, shielded bearing. This is the kind we have in the classroom. If you scroll down, you'll see the listing for it, 608 2Z. If you scroll over here, it has 5972K501. That's the part number that McMaster Car uses. If you click on that link, it's going to let you choose a CAD format down here. We're going to choose 3D SAT, and we're going to click Download. And what it'll do is download the CAD file for that and insert it into your design. It puts it at the origin, which is great. So I'm going to click OK. Just like when we did other things, the first piece that you put into a design, you want to ground it. So I'm going to go up here where it says the bearing here, right click, ground. I'm also going to rename this. If you click on the name here, the 5972, just click on it once and then click on it again. It's not a double click, it's 2 clicks right after each other, but with a little bit of time between them. And we can rename this. I'm going to say 608ZZ ball bearing. That's the real name. That's what people call these. That 5972 stuff was just McMaster Car's number, which only works for McMaster Car. So great. So now we got the bearing. On our document settings up here, these parts are metric parts. So we're going to use millimeters for this design. So right here where it says document settings, you can expand that. You can see units is inches, and you want to change this setting here. Over here, unit type, millimeter, hit OK. So cool. So now we're going to design this thing, and we're going to design it around this bearing. And we need to inspect the bearing to know how big it is. So we're going to figure out some things here. So if I click inspect, here there's a little ruler. It's a measure tool. You can get it off the menu also. Click the outer cylindrical surface. You'll see the diameter is 22 millimeters. So we know that. If you click this inner cylindrical surface, you'll see the diameter of that, which is, I guess I have to hit escape. Let me try it one more time. Click measure, click the inner cylinder. There we go. 8 millimeters, the inside diameter. So we've got 22 on the outside, 8 on the inside. We also want to know how wide is this bearing. So click the measure tool again. I'm going to click on this surface right here. Pivot around to the other side. Click on the same surface on the opposite side. And it's going to show you that the thickness of this bearing is 7 millimeters. So those are numbers that we'll need later. So what we're going to do now is we're going to sketch the rotor, which is the spinny part of the fidget spinner, and then we'll extrude it. So we're going to create a sketch, put it on the XY plane, boom, and we're going to start drawing. First thing to do is we want to make a hole in the piece where this bearing will go. So I'm going to create a circle. I'm going to start right here at the origin. I'm going to go out here. And we measured the diameter of the bearing. It's 22 millimeters. However, what will happen is the hole in the plastic, as the plastic cools in the 3D printer, it's going to contract and get smaller. So we have to make the hole slightly bigger than the bearing. And I've found that a good number to use for this is 22.1 millimeters. So I'm going to type 22.1 for the diameter of this circle and hit enter. You can see the dimension appears. I'm going to turn off the visibility of the bearing so we can just see our sketch. So that's where the bearing's going to go. The basic design we're going to do is just going to have 3 bearings in kind of a triangular configuration around the outside. So we're going to draw another circle. Anywhere above the first circle, just draw a circle. And we're going to use the equal constraint to make these two the same size. We're also going to use a vertical constraint to make these 2 circles be right above or below each other. Um, so it's still blue though, and the reason is it doesn't know how far to be away. So I'm going to do a dimension. I'm going to click the center points of this two circles with the dimension tool, and we're going to set this to 30 millimeters right there. Okay. So now we got holes for bearings. Now we need two more holes. We need one down here and one down here, but we're going to use a tool to create those automatically. So we'll just draw the top one and then use some tools to copy it around into a pattern. So I'm going to make another circle. This is going to be the outer edge up here on the top. I'm going to click on the center point and go out here. And then what I'm going to do is do a dimension, D for dimension, click on the inner circle, click on the outer circle, and I'm going to make this 4 millimeters. So I click and put 4. So it means we'll have a thickness of plastic. This will be the hole for the bearing, that edge right there. This will be the outer edge, and it'll have 4 millimeters of plastic out there. So that looks pretty good. And so we've got one of these done. Now we want to make the other two. So you could go down here and figure out the angle and draw it, but there's a really cool tool under Create called circular pattern. And if you click this, it's like we did rectangular pattern before. It'll make a grid shape of objects. You know, you draw one and then it'll make a line of them or a grid of them. Well, this one will make a circular pattern of them. So you can see it wants you to click objects. So I'm going to click on these two circles on top. And then it says center point. I'm going to click center point and click the center of the circle on the bottom. Then you get angular spacing full. Do I want to go around the whole circle? Yes. Suppress, I'm not actually sure what that means. I've never done that one, but quantity is 3, and you can see it's going to make 3 of them. Now you could play around with this. You could try different numbers. You know, when you're designing your own spinner, you can have fun with this one, but 3 is what we want right here. So we're going to click OK, and you can see it automatically makes the sketch for the other two circles. And any changes, if I were to change the top, don't do this, but you know, if I go up here and change this to 2, they all change together. So it's kind of rad. Um, so I've sort of got these circles, I've got the middle, but nothing's connecting them. So we got to draw an arc or another shape to connect. So what I'm going to do is draw an arc. I'm going to draw a 3-point arc. I'm going to click on one circle up here, go click on another circle down here. And then I'm just going to put this arc in here. I'm not even going to constrain it. You can see it wants to go tangent. I'm just going to let it float. So it's totally blue. Then I'm going to add the constraints. Tangent, arc, top circle, keep tangent on, arc, bottom circle, and you can see it looks a lot better. It's still blue though. What it needs is a radius. So I'm going to do D for dimension, click on the arc, and I'm going to place a dimension right here. It's going to be a radius. This is going to be 15 millimeters. Okay, and so you can see now I have this nice curve that connects these two circles. I don't have one on the bottom though. I don't have one on the top right, but I'm going to do the same thing I did before. I'm going to create a circular pattern. I'm going to click on the arc that I want a pattern of. I'm going to click center point, click the center of this center circle, and it will make your arcs. See, there's 3, click OK. And so that is the sketch for this. I'm going to finish my sketch. I'm going to go to my home view. I'm going to save this before I forget. And I'm going to call this the baseline fidget spinner. Okay. And the reason I'm calling it baseline is you guys are going to make an improved one later. This one is going to be like a basic one. I'll have you do this first and then take it and turn it into your own. So we'll call this the baseline fidget spinner. So now we need to extrude this. If you recall, the bearing has a thickness of 7 millimeters. So we need to extrude this 7 millimeters. However, look at how this is lined up. Let's go to the side view here. The sketch is on the center line of the bearing. So we need our extrude to go forward over here. And we also need it to go the other way. So that's a little weird. We've never done that before. I'll show you how to do it. All we're going to do is click extrude, dude. Click on this ring on the top, this kind of triangle-y bit in the middle, the other ring, and the other ring. And we want to extrude. And what we're going to do is instead of extruding to one side, which is what we normally do, we're going to extrude to symmetric. 2 sides will let you go forward and backwards at the same time in different amounts. Symmetric will let you go both ways at the same time, the same amount. So that's what we want is a symmetric. And then down here where it says measurement, you can either have half length or whole length. We want whole length. And then we're just going to put our distance in here, 7 millimeters, and hit OK. And you can see it makes this piece here. And if I look at it over here, it looks pretty good. It's flush. Everything looks great. We're going to add one more feature to this. We're going to fillet this. So I'm going to choose a fillet tool. I'm going to click this front edge and this back edge. And the radius I want to use is 3.5. And I chose 3.5 because it makes this fully rounded. It's basically 3.5 is half of 7. So it makes it a full round, which looks pretty cool. It feels good in your hand. You can click OK. A couple more things to do. So we have one component here, which is a ball bearing. It's good when you have something like this to take your bodies that you've created and turn them into components so you can use them in other designs. So right here where it says bodies, I'm going to expand that. And you can see I have body 1, which is the extrusion I just did. You can right click on this, create components from bodies. You can see it'll make component 2. We're going to rename that, click on it, wait, click on it again. We're going to call this the rotor. And that's just a term in any kind of engineering system where you have something that spins. You call it the rotor. And you can see it looks like it's metal. Well, we're going to 3D print this out of plastic. So we're going to right click on it and choose a physical material. And the plastic we're using in the laser cutter is called PLA, polylactic acid. It's not on the list though. So I'm just going to choose plastic. And then if you scroll down here, there's a generic plastic. It just says, where is it? I thought there was one that just said plastic. There it is. It just says plastic. We'll just use that one. Drag it on there. Boom. That changes the physical properties. If you're okay with that color, it's kind of an off-white. That's fine. You can always do appearance and, add an appearance. You could make it, glossy blue or green or gray or white. Any one of those colors is fine. I'm just going to leave it as the basic color. And so at that point, I just hit save.